In this lecture, let me talk about RFlex assembly mode. By importing an RFI file, an RFlex body is created. How to import an RFI file is similar to importing meshes of Reflex. There are three options when importing an RFI file. The most common option is body. At this time, the original body disappears and it is replaced with the imported RFlex body. Since the RFI file contains dimension information, there is no need to specify the unit when importing an RFI file. After clicking Import RFI, specifying a point, then selecting an RFI file, then an RFlex body is created. In the dialog box of RFlex body, there are three additional tabs that the rigid body does not have: FInfo, RFlex, Node Scope. FInfo shows the mesh information of a flexible body. The number of nodes and the number of elements are displayed. You can also check the number of elements based on each element type. It is possible to open the display dialog box by clicking the display button. RFlex tab shows information about an RFI file and modes. First, RFI file path is displayed. Even after importing the file, the RFI file must exist to use the RFlex body properly. Also, if you select each mode, you can check the mode shape as animation. Users can specify which mode to use for the simulation. Modes with frequencies close to 0 are usually rigid body motion, which are not usually suitable for simulation. Modes at low frequencies are the shapes that appear easily, and the modes at high frequencies are hard to appear. Therefore, mode shapes with high frequencies above 10,000 Hz are sometimes excluded from the simulation. To learn how to select the appropriate number of modes, please refer to the technical tip at the following link. In a flexible body, the node results are written to the results file only when the nodes are defined as output. However, it is possible to check the results of nodes that are not defined as output. Select non-output node and select the node you want to check the result of. The result is plotted in the scope dialog box. I will show you how to check the mode shape of an RFlex body. As you can see, if you select a mode from the table, the shape of that mode is shown as animation. RFlex body marker is almost similar to FreeFlex body marker too. Here is what to know about marker. The markers belonging to the rigid bodies are connected to the body directly, but the markers belonging to the flexible bodies are connected to one specific node, and the relative position between the marker and the node does not change. So, in the RFlex body marker dialog box, the reference node ID and its relative displacement are displayed. By default, when a marker is created, it is connected to the node closest to the marker. When converting a rigid body to a flexible body, the joints and forces are preserved using the G-modeling technology. But sometimes, users need to create new joints, forces, and contacts. Basically, you can create them in the same way as a rigid body. However, in the case of joint and force, FDR must be created in advance, and joint and force must be created on the FDR's master node location. For contact, it is recommended to use the GeoSurface contact series. For 3D contact, you need to create a patch set in advance. For 2D set, you need to create a line set and define the contact using them. Frankly speaking, this is a FreeFlex demo model, but joint force contact creation for RFlex is the same as FreeFlex. The joint is created on the master node location of the FDR. The contact is created between a rigid sphere and a patch set of a flexible cylinder. After running a simulation, you can see that the joint and contact work properly. But since this is RFlex, RFI file must include the constraint mode for the FDR and the nodes around the contact area. RFI Optimizer is a tool to reduce RFI file size. For large flexible body models, the RFI file can be several gigabytes or bigger. Huge RFI files affect computation speed and animation performance. In this case, you can use the RFI Optimizer to reduce the RFI file size. You can reduce the file size by removing data that is unnecessary in this simulation, or by using float instead of double. Strain-stress shape generation is also called strain-stress recovery. After simulating the model including RFlex bodies, the strain-stress shape is needed to calculate the strain-stress. If there is no strain-stress shape in the RFI file, strain-stress shape needs to be created using this function, and then they are added to the RFI file. These are 4 functions in modal force and pressure. Out of these 4, load case and preload are rarely used, so I will skip them. You just remember modal force and pressure. In case of modal force, the modal force U sub ext type is mainly used, and the load is applied to the specified node set. Pressure applies pressure to the specified patch set using expression. You can use contact for RFlex body, but please keep in mind that RFlex contact has some limitations. The contact point must be invariant, and the deformation caused by the contact must be small. In addition, the constraint mode for the contact points needs to be calculated, or the mode shape similar to the shape deformed by contact must be used. Otherwise, the accuracy of the RFlex contact can be low. RFlex contact supports various combinations like an RFlex body and a rigid body, or RFlex body and a full-flex body. Just like a full-flex contact, you need to create the patch set or line set in advance. I will end this lecture here and continue it in the next one. After watching all the MFBD kit courses, don't forget to try the workshops in the below link here. Thank you.